We're going to talk about one-sided limits and the existence of a limit. If you guys think of that movie Mean Girls, it's an all-time classic. Note, that's my mom's favorite movie. So bizarre. Anyway, you remember that scene where she says, the limit does not exist. And now we can understand when a limit might not exist. So if you look at this notation here, that really irritates me when that happens, and you guys know that happens a lot. Anyway, we have something when we could have a limit from the left, and we could also have a limit from the right. And if you guys notice this notation here, it's saying the limit as x approaches c from the left of f of x. And here it says the limit as x approaches c from the right of f of x. So now, instead of saying, okay, well, what is the limit, we're really just focusing on what is the graph approaching as we approach this letter C, but only coming from the left side. Should I explain that better? Yes, obviously. Okay, here's a graph. Let's say that this is C, and here's my, I don't know, this is clearly a polynomial function. So I want to know, for example, you know, as I am approaching C, coming from the left side, because that's what that minus right here represents, coming from the left side, what are my y values approaching? What are they getting closer and closer to? Same thing here. What are my y values as I come from the right side of my graph, approaching as I approach C? So, the existence of a limit. Let f of x be a function and let c and L be real numbers. The limit of f of x as x approaches c is L if and only if the limit of f of x as x approaches c from the left is L and the limit as x approaches c from the right equals L. In other words, what this is saying is that, let me just write this down for a second. Sometimes it's hard to write and think. What this is saying, this notation means that you're looking for a limit, right? This is the limit as x approaches c of f of x. You're looking for a limit from both the left and right. So in other words, in order for a limit to exist, the limit must equal the same number both from the left and right-hand side. Okay. So let's take a look at some examples, and maybe this will help us understand better. So we're asked to evaluate the limit. So we're going to find the limit as x approaches 2 from the left. We're going to evaluate the limit as x approaches 2 from the right. And we're also going to evaluate the limit as x approaches 2. Okay? So I want you guys to think about this. If you're unsure, maybe take a look at the graph. You could look at the graph. You could look at the table. But I want you to think, what is the limit from the left? So go ahead and put me on pause and take some time to think about it. So let's take a look here. So the limit as x approaches 2 from the left is -1. We'll see why in a second. The limit as x approaches 2 from the right is 1. And now, I mean, this problem really just separated the theorem that we just talked about before. You know, what does it take for a limit to exist? Well, the limit does not exist at x as x approaches 2 because the left-hand limit and the right-hand limit don't equal the same thing. One approaches -1, one approaches 1. So it's not possible for us to approach the same number in both directions. Let's take a look at this graphically. So I plugged this into my graphing calculator. Let's take a look at the table first, because I think that that's not the first thing you would do. Anyway, so here's 2, and I notice that as I am approaching 2 coming from the left, or values below it, they're all approaching -1. So that's why that limit was -1. As I'm coming from the right, or values that are slightly above 2, notice that they're approaching 1. So if I look at my graph, I can see this here. And that's why at 2, we say that the limit does not exist. Because coming from the left-hand side and then coming from the right-hand side, they don't approach the same value. So how can that limit exist? It doesn't. Okay, let's try this one. We want to evaluate this piecewise function. And you're going to have to really understand what each of these represent in terms of, is it a left-hand limit, is it a right-hand limit? And maybe you also want to plug it into your calculator. You could do both. Okay? So go ahead, put me on pause, and let's see what you can do. Piecewise functions. So the first thing that I'm looking at is like, what does this even mean? So I have x squared plus 1 when x is less than 2. Well, when x is less than 2, that would be x approaching 2 from the left. Okay, so I can evaluate this by finding the limit as x approaches 2 from the left of f of x. Well, if I plug in 2, I get 5. Also, for this part where x is greater than 2, well, that would be x approaching 2 coming from the right side. So if I evaluate this limit, I also get 5. And because the left-hand limit and the right-hand limit, or in other words, the limit as x approaches 2 from the left and the limit as x approaches 2 from the right both equal 5, therefore the limit of f of x as x approaches 2 equals 5. One thing I want you to keep in mind is that the domain of this piecewise doesn't include 2. Notice that it would be really all real numbers except x doesn't equal 2. But even though f of 2 doesn't exist, right, because if I said, oh, well, what's f of 2? And you wouldn't be able to plug it into either piece, right? So it doesn't exist, but the limit does. And that's okay. That happens, okay? Let's think about this graphically again. So I plugged both pieces into my calculator, which I didn't include the restrictions just because I'm kind of lazy. If we go to the table, so here are the y values for the first piece here. And if I kind of scroll up, coming from x is less than 2, notice that we're approaching 5. I could have made these smaller increments so that way I could really see that better. And then, for my y2, that would be this portion of the piecewise function where x is greater than 2, same thing. I know that they're starting to approach 5 as well. And if I take a look at my graph, well, graph's not going to be helpful because I didn't restrict it. My bad. Okay. All right, so in conclusion, limits, when we're looking for limits, think about what is the y value approaching at a given x value. We can look at the graph from the left and the right. We can also look at the table from the left and the right.